So today we are going to start the new chapter, chapter number 9, that is circles, right? So in this chapter we are going to learn so many theorems related to circles and we will learn how to apply these theorems to do the questions, right? So as you are very familiar, like what is a circle, right? Circle is the locus of a point which moves in a plane in such a way that its distance from a given fixed point is always constant, right? So if you take any point on the circle, the distance of that point from the center of the circle is always same, and that is radius, right? So there are so many terms which are related to circle which we should know before understanding the theorems, right? Like the circumference, right, which is the length of the boundary. Radius, which you already know. Okay. Chord, chord of the circle. Chord of a circle is the line segment joining any 2 points on the circle, right? So if we have suppose 2 points on the circle and we join those points with a line, a straight line, that is a chord, right? Suppose this is a circle and we have 2 points here. This is A point, this is B point, and we draw a line joining these 2 points, right? So this line is called as chord, right? So these are certain terminologies which we should know, right? Okay, so a circle is having a center, right? This is the center O of the circle. Okay, the distance of the center and any point on the circle is always same. Suppose this is point P, right? And the distance of O and P is always same, right? Okay, if you take any point and if you take the distance from the point, the center of the circle, that is always same and that is called the radius R, right? Diameter of the circle is a, you can say a diameter is a chord of the circle joining, you can say which pass through the center of the circle, right? So if we draw a diameter here, right? So this will be the diameter here, okay, which is passing through the center of the circle. Suppose this is A dash and B dash. So here A dash B dash is the diameter, right? Okay, so what is the diameter? Diameter is the longest chord of the circle which passes through the center. Okay, is that clear? So any chord which is passing through the center, joining the 2 points on the circle, is a diameter. Okay, so what is the diameter? Diameter is a chord of a circle passing through the center of the circle, right? And there is a relation between the diameter and the radius. That diameter is always the twice of the radius, which you already know, which you have already learned in your previous classes, right? Similarly, we talk about the circumference, right? Circumference is the length of the boundary, right? Means if you take a cut from here, right? This point is C, right? Suppose this whole circle is made up of a wire and you will take a cut here at point C and open this wire, then the length of the wire will tell you the circumference, right? So circumference of a circle is equal to 2 pi r, right? Is that clear? Circumference of the circle is 2 pi r, where r is the radius, or you can also say that this is pi into d, where d is 2r, right? Okay. So this is the ratio, right? Circumference and diameter, right? C upon d ratio, right? If you take d to this side, C upon d, this is always equal to a constant, and this constant is called pi, right? And its value is always 22/7, or in decimal, we can take it as 3.14. So mathematicians have, find it out like if there is a circle and if you find a ratio between the circumference and the diameter of any circle of any radius, right? It is always a constant. That constant is 22/7. And this is how we get the formula for the circumference. Is that clear? This you have already learned in your class 7 and class 8, right? We are just revising it, right? Then if we talk about the secant of the circle, right? So if suppose we have a circle, suppose this is a circle, right? Then what is the secant? A line which intersects a circle in two distinct points is called the secant of the circle. So if suppose we have taken a line here, right, which is passing the circle at two distinct points, suppose A and B, right? Then this line is called as secant. Is that clear? Okay. Secant of the circle having radius O, right? Then there is tangent also, right? And now what is tangent? Tangent is a line that intersects the circle in exactly one point, right? Secant touches the circle at two distinct points, but tangent intersect the circle in exactly one point, right? For example, like this. So if there is a line which touches the circle at just one point, suppose this point is P, then this line is called as tangent to the circle. Is that clear? So there is a difference between tangent and secant. Secant intersect the circle at two distinct points, whereas tangent always intersect the circle in exactly one point. Okay, and the point at which the tangent meets the circle is called the point of contact, right? So here the point P is called as point of contact, right? So at any one point, at a point, there is only one tangent which can be passed through it, right? Then we can have the areas, interior area of the circle and the exterior of the circle. So any point which lies inside the circle, right, which we will say that that point is inside the circle, right? Okay. So region here, this region is the interior part of the circle, whereas the part outside here is the exterior of the circle. So this is exterior region of the circle. This is the interior region of the circle. And if there is any point which lie exactly on the circle, we say that this point lie on the circle, right? Is that clear? Now, there can be concentric circles, right? So what is the meaning of concentric circles? If suppose we have two circles such that they're having different radius, but their center is same, right? Okay, center of the circle are same, right? For example, like this. Okay, so you can see here there are two circles, right? Their center is same, but the radii are different. Yes or no? The radii are different. Okay, so suppose this is R, capital small r, and this is capital R, right? So capital R is greater than small r, right? So these two circles are called as concentric circles. So such circle are called as concentric circles, right? So what are concentric circles? Circles which have the same center but different radii, right? What are the property? They are having same center but different radii. Okay, so such circles are called concentric circles, right? Now, what do you mean by the arc of the circle? Arc of the circle. Suppose we have a circle. Okay, this is a circle. Now, the center is O. Okay, and here we have taken 2 points A and B. Is that clear? So you can see that this AB, right? ACB from here to here, from this point to this point, this is the part of the circle, right? This is the part of the circle, right? And this part of the circle, the continuous piece of the circle, right, is called arc. So we called it as arc, right? Okay. So what is the name of the arc? Arc ACB, right? And how we denote that? Arc ACB, and we put a curved line over it, right? This is just a symbol to write then arc, represent an arc. Okay. Similarly, so this is an arc ACB, right? Similarly, you can have another arc, right? The bigger arc. Suppose this point is D, right? So this arc is called ADB, right? So this is also an arc, which is the part of the circle. So arc is a continuous piece of a circle, right? Is that clear? Okay, having the same radius. Is that clear? Okay. Now, semicircle. What is semicircle? If we divide a circle into two equal half, suppose this is a circle, right? And this is the center of the circle, O, right? Now we divide this like this. Okay, so this line AB divides the circle into two equal half, right? Okay, so each one of them is called semicircle. This is a semicircle. This is also semicircle, right? So if we divide the circle into two equal half, then each part of the circle is called a semicircle, right? Semicircle can also be called as that a diameter of a circle divides it. We can divide it into two equal arcs. Then each one of the arc is called a semicircle, right? So if we take a point here C and here we have take a point at D, then ACB and ADB are two semicircles, semicircular arc, right? So what are these? These are two semicircular arcs. Okay. We can also measure the degree measure of an arc, right? How we can measure what will be the degree of the arc? This we can measure that. Suppose A and B here, as we have taken here, A and B, this is an arc, right? ACB is an arc. Now, if we join these 2 points, A point and B point from the center, right? Okay, so you can see that these two lines, AO and BO, right? They're making an angle, right? And just suppose this angle is theta degree, okay? This is theta, right? And if suppose angle AOB is theta, right? AOB is theta degree, then we say that degree of arc AB is theta, right? So what is the degree measure of arc AB? Degree measure of arc AB or ACB is theta, right? That means the two extreme point of this arc, right? When we join these 2 points with the center, they make an angle, right? And this angle is the measurement, degree measurement of the arc, right? So whenever we draw an arc, we can find out the length of the arc, we can find out the degree of the arc, which it subtends at the angle, and we can also find the area of the sector, right? Okay, I will tell you what is the sector, right? So whenever we are taking an arc, right, there may be some minor or major arc, as in the case of this first figure. So here ACB is the minor arc, where ADB is the major arc, right? So this is the major arc, means this arc is big in measurement, right? And it is subtending a greater angle, and ACB is the minor arc, right? Okay, so in this way we can say what is major arc and minor arc of the circle, right? So when we divide the circle exactly from the diameter, then both the semicircular arc are same in, they are same in measurement, right? Both are subtending an angle of 180 degree. So this is also 180 degree, this is also 180 degree, and therefore both the arcs are same, right? But when one is smaller and another is bigger, then we can say a minor and major arc. Everybody getting till here? Yes or no? Now, after this, we can also, we can have the different segments of a circle, right? Suppose we have a circle. This is a circle, right? And we draw a chord here, right? This is a chord joining the 2 points on the circle, right? This is center O, right? Right. So you can see here that ACB here is an arc. Just look at what are the terminologies, right? So what is the arc here? ACB is the arc, okay? AB is the chord, right? ACB is an arc, right? And this arc and this chord divides the circle into 2 parts. Yes or no? Into 2 segments, right? This is the minor segment, and the other part of the circle is the major segment, right? So you can see that this arc and this chord, right, divides the circle into 2 segments, right? So this upper one is the major segment, the below one, right, is the minor segment. Is that clear? Everybody understood this, right? So part of the circular region bounded by an arc and a chord, right? So what this segment is made up of? This is a segment. And how this is made up of? This is made up of an arc. Okay, this is an arc, and this side it is a chord, right? So this is bounded by an arc and a chord, right? So this part is called the segment of the circle, right? Now it depends like what is the length of the arc. Accordingly, we can say that this is a minor arc and other is the major arc, right? So here ACB is the smaller arc in comparison to ADB, right? ADB is the bigger arc, right? So that's the reason this is a major segment. This is a major segment, right? And the below one is the minor segment. So segment of the circle is always bounded by the arc and a chord. Is that clear? Okay. Now, what do you mean by sector of a circle? Right? What is the sector of a circle? Suppose we have a circle, okay, having center O, right? Now, again, we have an arc here. Suppose AB is the arc, right? Now, if we join A and B with the center O, right? So each one of them, OA and OB, both are the radius of the circle. Yes or no? Both are the radius of the circle, and this side you have the arc AB, right? Okay. So what is the sector of the circle? The region which is enclosed by an arc. This is an arc AB of a circle and its two bounding radii, right? So this is the radius. This is also a radius, right? So a region which is enclosed by an arc and it's the radii of the circle is a sector of the circle. So what is this portion called? This portion is called sector. Is that clear? What is this? This is the sector of the circle, right? Which is bounded by the arc AB, right? So this is the arc AB. Okay. This is also a radius and this is also a radius. So sector is always bounded by the radii, the two radius and the arc. Is that clear? And this closed region is called the sector of the circle. Everybody understood, right? And this angle at the center made by these two radii is called the angle subtended by this sector or the arc, right? Now, similarly, we can also have a quadrant of a circle. If we divide the circle into 4 equal parts, then each part will be called as quadrant of a circle. Suppose there's a circle. Now, if we suppose divide the circle into 4 equal parts, right? This is also a diameter. This is also a diameter, suppose, right? This is the center of the circle, right? This is radius, this is radius. Then this is called quadrant of the circle. Means 1/4 part of a circle, right? Semicircle, when we divide the circle into 2 equal half, that is a semicircle. If we divide circle into 4 equal half, then each of this part is called the quadrant of the circle. Is that clear? Now, let's see what are congruent circles. Congruent circles. Congruent circles. Now, what are congruent circles? Two circles. For example, as you can see here, the figure CO, comma R, this one, and CO dash, comma S, right? So these two circles these are said to be congruent only when R and S are equal, right? What does it mean? Means the circles having equal radii are congruent circles, right? So two circles are said to be congruent when they have equal radius, right? When their radii are equal, when their radii are same, right? Then in that case, we say that the circles are congruent. As you can see here in this diagram, R and S are equal. Then both the circles CO, comma R and CO dash, comma S are said to be congruent, right? So two circles are congruent if they have equal radii. Now, what is cyclic quadrilateral? Cyclic quadrilateral is a quadrilateral. Suppose we have a quadrilateral ABC, ABCD. It is said to be cyclic if all its vertices means A, B, C, D, these are the vertices of the quadrilateral, these lie on a circle. When all the vertices lie on the circle, we say that quadrilateral as a cyclic quadrilateral. And these points, A, B, C, D, which are lying on the same circle are called concyclic points, right? That means if suppose we have a circle, suppose there's a circle and there are 4 points on it, A, B, C, D, right? Okay. Now, suppose we draw a quadrilateral here, joining these 4 points like this. Okay. So now this quadrilateral ABCD, right? This is cyclic quadrilateral, right? Is that clear? Why this is cyclic quadrilateral? Because all its vertices lie on the circle, right? And these points A, B, C, D, the points A, B, C, D are called concyclic points. So these are concyclic points. So here, these points A, B, C, D are concyclic because all these points lie on the same circle. Okay, so suppose there are many points, multiple points, 2 points, 3 points, which are lying on the same circle. These points are called as concyclic points, right? For example, it is exactly similar to the collinear points. When there are number of points, more than 3 points, which are lying on the same line, we call them collinear points. Similarly, when you have 2 or more than 2, right? More than 2 points which are lying on the same circle are called concyclic points. Is that clear? So vertices of the cyclic quadrilateral are concyclic. That means these vertices lie on the circle, right? Such quadrilateral is called cyclic quadrilateral. Is that clear to everyone? Yes or no? So congruency of circle is your first theorem in this chapter, okay, which I already explained you, that two circles are congruent if and only if they have equal radius. If they have equal radii, then we say that two circles are congruent. So here the two circles, right? CO comma R and CO dash comma S, right? These are the two circles and they will be congruent, right? That means if R is equal to S, then CO comma R will be congruent to CO dash comma S, right? So if the radius are equal, then the two circles will be congruent, right? That means what is the meaning of congruency? It means that if we place one circle over the other, right, they will coincide. Their center will coincide. They superimpose each other. They totally cover each other, right? And such figures are called congruent figures, right? Okay, so here these two circles CO comma R and CO dash comma S will cover each other completely if you put one over the other, right? Means the two circles will be congruent and they have equal radii, right? So can you say that if they are having equal radii, they will be having equal area? Yes or no? Right? So if the two circles having equal radii, it means they also have equal area, right? So what are the congruent figures? Congruent figures means having equal size and shape, right? Their area must be equal. Are you getting that? So if these two circles are congruent, then area of C circle CO dash R is equal to area of CO dash comma S, right? So if the two circles are congruent, their area will also be same, right? So this is theorem number 1 in this chapter. I hope you have understood this. Yes or no? Now look at theorem 2. Theorem 2 says that equal chords of a circle subtend equal angles at the center. As I already told you, what is the meaning of the chord, right? And how they are subtending the angle, right? So if there are two chords in the circle which are equal chord means they are equal in length, then the angle subtending by these equal chords will also be equal, right? This is a theorem, right? We will prove this also, right? So what it says that if we have two chords which are equal in length, right? So what is given here? It is given here that there is a circle. You can see here there is a circle, C suppose, with center O and radius is R. Okay. And in this circle, chord AB, the chord AB, this is the chord AB. This is equal to the chord CD in length, right? Okay, so chord AB is equal to chord CD, right? Because it is said here that equal chords means these two chords are equal in length, right? So this is already given here, right? That these two chords are equal in length. So now what we have to prove? We have to prove that angle AOB this one, which is subtended by the chord AB, and angle COD is this, which is the angle subtended by the chord CD at the center, right? So what we have to prove that angle AOB is equal to angle COD, right? What is angle AOB? AOB is the angle subtended by the chord AB, right? And angle COD is the angle subtended by the chord CD at the center. Is that clear? And we have to prove this, that these angles are equal in measurement. Is it clear? They are equal in measurement, right? So how to prove this? Now look at the proof. Now look at these two triangles. In triangle AOB and triangle COD, right? We have two triangles here, triangle AOB and COD, right? So consider these two triangles. What we have here, OA is equal to OC, yes or no? OA, this is equal to OC, this. Why? Because both are the radii, both are the radius of the circle, right? So both are having the same length. This is also R, this is also R, radius of the circle. All radius, we can have infinite number of radius in the circle and all are equal in length, right? So OA will be equal to OC, right? Each equal to R. Getting that? Right? Now OB is equal to OD. Now this side you can see here, this one, OB and OD will also be equal. Both are again, these are the radius of the circle, right? They are also equal to R, each equal to R. Okay. And AB is equal to CD. AB and CD chord, this is already given here, that the chord AB and CD are equal in length. This is already given that AB and CD are equal, right? So these two lines are equal, right? These two sides of the triangles are equal. This is also equal and this is also equal, right? It is already given here. So can we say that these two triangles are congruent to each other? Yes or no? We have already studied about the congruency, right? The different congruence criteria. So by which congruence criteria they are equal? They are congruent by side, side, side. By SSS congruence criteria, we can say that triangle AOB is congruent to triangle COD by SSS congruence, right? So by using this congruence criteria, congruence law, congruence rule, we have proved that these two triangles AOB and COD are congruent to each other, right? Now, since these are two congruent triangles by CPCT, right, means the other corresponding parts of the congruent triangles will also be equal, right? So from here, we can say that triangle AOB, sorry, angle AOB is equal to angle COD, right? Both angles will be equal. Why? Because these are the angles of the congruent triangles, right? So by CPCT means corresponding parts of the congruent triangles will also be equal. We have proved that these two angles subtending by the equal chord are also equal, right? So that's how we have proved this theorem, that equal chords of a circle subtend equal angles at the center, right? So if there are two equal chords, then the angle subtended by these two chords at the center will also be equal. Is that clear to everyone? Yes, sir.